This is about quasi-state or fast state associated with adiabatic process. An adiabatic process is about a pressure differential where a piston can be compressed or expanded and no heat will escape the pipe. Now, a quasi-state means that the piston will be moving quite slowly. Here is an equation for an adiabatic process. However, this situation will be somewhat different if the piston is moving very fast, compressing very fast, or expanding very fast. As we can see before, if the piston is moving quite slowly, the air inside the pipe will get hotter as it gets compressed. And if the piston moves backward and allows the air to expand, it will get colder. The way it gets hot as it compresses is that the piston is pushing the particles as it moves forward. Let's say that the piston is not moving. The particles will simply bounce off, bouncing back and forth at the same speed or the same temperature. Now, if the piston starts to move forward, it will be pushing these particles as it moves forward, making the particles move faster, therefore making the air get hotter as it gets compressed. The opposite occurs as it expands. As it slowly expands, the air particles will be moving toward the piston, but since the piston is moving away, the particles will be bouncing off the piston slower than they were moving toward it before because the piston is moving away. So as I said before, if you compress the air will get hotter, and if you allow the piston to expand, the air will get colder. But there will be a different situation. The piston is moving very fast in either direction. Let's say that this piston simply pops up to the top very fast. The air will now be able to expand into the vacuum. However, they will not be bouncing off the piston as it's moving because the piston just suddenly popped up to the top, and the piston will stop at the top. So once the particles reach the piston, they will be bouncing away from it the same way as the piston was sitting there before. Again, if the piston suddenly pops up to the top, the air will just flow up to the top and will not be bouncing off the piston as it's moving. Before, as the air was bouncing off the moving piston going up, the air particles bounced off slower than as they moved toward it. Another interesting thing that happens if this piston suddenly pops up to the top is that as the air makes its way up to the top, the temperature throughout the pipe will actually not be the same temperature throughout the pipe. As the air begins to move up quickly, it will freely go up. Those particles will be moving at the same speed as they were moving before. Once some particles are at the top, there will be a low pressure at the top and a still higher pressure at the bottom. Now more particles will start to move going up. However, when this happens, the bottom part, which has higher pressure, will be pushing the particles against the low pressure area above. So the low pressure at the top will be compressed, getting a bit hotter, and the bottom part will be pushing the top, getting colder. So as you can see here, if that piston suddenly pops up to the top part will end up being a bit warmer, and the bottom part will end up being a bit colder. Now let's say that the air gets compressed very fast. In this case, the whole air will get quite hotter than if it gets compressed slowly. This is because if the piston is compressed very fast, not only does it hit the particles that it would be hitting if it gets compressed slowly, but it hits even more particles. Because if the piston was going slowly, it would only be hitting particles that are moving toward the piston. However, if the piston is compressed very fast, it will be hitting particles that are already moving slowly away from it. Because if the piston is moving so fast, it can hit some particles that are even hitting away. As the piston compressed fast, it will create a sine wave that will move back and forth and eventually turn up into heat. So during an adiabatic process, if the piston is going slowly up, the air will get colder, and if it gets compressed slowly, it will warm up. But if the piston goes down fast, it will make the air hotter. And if the piston pops up incredibly fast, the average temperature of the air would not go down, but some of the air would get colder and some of the air would get hotter.
Thanks for watching.